This problem says a child's electronic supplied by three 1.5 alkaline cells having internal resistances of zero point 0.2 ohms in series with a 1.53 volt carbon zinc dry cell having a 0.1 ohm internal resistance. The load resistance is 10 ohms. Draw a circuit diagram of the toy and its batteries. Okay, so you have three 1.5. Okay, so 1.58. And the internal resistance 0.2 ohms, 8. .58, 0.2 ohms. And then in series with the 1.53 volt internal resistance of 0.1 ohm. Now these are all 0.02 ohms. And then the load resistance is 10 ohms. Okay, so there's the circuit diagram, and part B, what current flows I is voltage over resistance, and the voltage is the net voltage, the current 1.58 plus 1.58 plus 1.58 plus 1.53, and the resistance is 10 plus 0.1 plus 0.02 plus 0.02 plus 0.02. So the current is 6.27 volts divided by 10.16 ohms, and this is equal to 0.62 amps. So the current through the toy is 0.62 amps. How much power is supplied to the load? So in the load, power to the load is current times the resistance of the load, which is 0.62 amps squared times 10 ohms. .8 watts, and then another page below. And then how much power is supplied to the load? What is the internal resistance of the dry cell if it goes back, resulting in only 0.5 watts being supplied to the load. So you get the dry cell. Okay. So if the power to the load is 0.5 watts, which is down from 3.8 watts, it's I square R load. I would be 0.5 watts. The load is 10 ohms, square root of that, and that would be So the current will drop to 0.22 amps, and so if the current is total voltage over resistance, the total voltage in the circuit is 6.27 volts, and that's so the total resistance would be 6.27 volts divided by 0.22 amps, which would be 28.5 ohms. Okay, and so the resistance of the dry cell would be 28.5 ohms minus 10 minus 3 times the internal resistance of the other batteries, or 2 ohms. So that's 0.06, 18.44 ohms. So the internal resistance of the dry cell went from 0.1 ohms to 18.44 ohms as it died. Okay, that finishes that problem.